Okay, good morning, everyone. Okay, good morning, everyone. Welcome to today's class. Before we start with today's topic, okay, we'll just do a quick revision of yesterday's class. Okay, in yesterday class, we learned about the concept of shear strength and why we should be studying this concept and what are the different theories put forward uh, to determine the shear strength. Okay, there is Moore's theory, there is Coulomb's theory. Coulomb's theory says that okay, shear stress is a function of normal stress, and this function or this relation is linear. Moore's theory states that okay, shear stress is function of normal stress, but this relationship is not linear, but it is curved. But for it also says that the more this linear relationship, it is okay tangential to the Morse circle. So we'll just combine both the theories. We'll modify them for ours to simplify our effort and calculation. Okay, we'll assume that the strength envelope is okay. The relationship is linear and it is tangential to the Morse circle. So this is our strength envelope or failure envelope. Okay, and this strength envelope or failure envelope, it is tangential to Morse circle. And the equation of the strength envelope or failure envelope is okay, tau is equal to C plus sigma into tan of phi, where C is cohesion and phi is angle of internal friction. C is y-intercept and it is cohesion of the soil. Phi is the angle of slope and it is the angle of internal friction or angle of shearing resistance. So this is about the more Coulomb's theory. Please, this is very important. Okay, as you increase the normal stress, the shear stress that is induced in the soil, it is going to increase. Okay, and this relationship is assumed to be linear and tangential to the Morse circle. And the equation of this strength envelope or Morse envelope or failure envelope is tau is equal to C plus sigma into tan phi. Y is equal to mx plus C. Okay, C is the y-intercept, phi is the angle of slope. Okay, so just remember this: when you apply load on the soil, okay, shearing stresses are induced in the soil. Okay, and when these shearing stresses they reach a limiting value, shear deformation takes place, and this leads to failure of the soil. So soil fails by shear. It does not fail by bending, it does not fail by buckling, it does not fail by torsion or whatever. It fails by shear, and hence calculation of shear strength becomes very important when you are analyzing soil. Hence, uh, so moving on, first let us see what are the factors that are affecting uh, okay, shear strength. Okay, the first topic of today's lesson is factors affecting shear strength. Now, the factors that are affecting shear strength. Okay, the factors that are affecting shear strength, it can be grouped into three categories. The first one being soil composition. The second is initial state, and the third is structure of soil. Okay, soil composition, initial state, and structure of soil. Now, soil composition means what minerals the soil are composed of. When we were dealing with clay mineralogy, we saw different type of group of minerals that are there in the clay, like kaolinite, montmorillonite, and illite. So, the mineralogy of the soil and what is the grain size of the soil. Okay, depending on the grain size, the soil is divided into gravel, sand, uh, clay, and silt. Okay, so what is the grain size of the soil and what is the grain size distribution of the soil mass? What is the shape of the particles? What type of pore fluid is present, and what is its extent of content, and what type of fluid is present in the pore. So when I say soil composition, all these things comes into picture. The next group is initial state. Initial state, okay. The state of a soil, it can be described by various parameters such as loose soil, dense soil, or whether it is over consolidated soil, normally consolidated soil, whether it is a stiff soil, soft soil, etc. So state of the soil also comes into play uh, when it comes to shear strength of the soil. Next is structure of the soil. Okay, when I say structure of the soil, it refers to the arrangement of the particles within the soil mass. That is, the manner in which the particles are packed or distributed. Okay, features such as layers, that is stratification of soil, or voids that are present, or pockets of air that are present, cementation, extra. Okay, they are part of structure of soil. Now all these things, they are going to affect the shear strength of the soil. Now the shear strength of cohesive soil, the factors that are affecting shear strength of cohesive soil and cohesion-less soil. Yesterday I explained you what is cohesive soil and what is cohesion-less soil. Okay, cohesion means, in simple words, cohesion means stickiness. Okay, the soils which are not sticky like sands, they are cohesionless soil, and the soil which are very sticky such as clay, they are cohesive soils. So please remember, um, cohesionless and cohesive soils. When I say cohesion less, okay, it means sand. An example of cohesionless soil is sand. An example of cohesive soil is, okay, we can say it as clay. Here there is no, in rough terms, there is no stickiness. Okay, here there is stickiness. So please remember, in shear strength of the soil, in this concept, we will be using these terms: cohesion-less soil and cohesive soils. And you should know the meaning of both. what is cohesion, what is cohesive soil, and what is cohesionless soil. Moving on, the factors that are affecting the cohesive soils. Okay, first is factors affecting shear strength of cohesionless soil. Okay, the first factor that affects the cohesionless soil is the shape of the particles. When I say shape of the particles, okay, the shape of the sand particle, it may be angular, it may be rounded, okay, or it may be flaky, the edges may be sharp or whatever. Now the shape of the individual soil particle. Now the shear strength of the sand with angular particles is more than that of rounded particles. For angular particles, okay, shear strength will be more, and for rounded particles it will be less. If the soil mass contains angular particles, uh, its shear strength will be more compared to that of soil mass uh, containing rounded particles. Okay, so the next factor is gradation. You have learned about gradation in your first module. Okay, whether the soil is well graded, soil is poorly graded. Okay, or if the soil is uniformly graded. Well graded meaning particles of all the sizes are present in the soil mass. Poorly graded meaning some particle sizes may be missing, or uniformly graded meaning only one particle size is present. So when it comes to gradation, well graded, okay, the symbol for well graded is WG. Well graded soil have more strength, shear strength, compared to poorly graded or uniformly graded particles. The next factor that affects the shear strength of cohesionless soil is denseness of the soil. Denseness meaning density of the soil. Now, I told you the factors that contribute towards the shear strength of soil is interlocking of the particles, friction between the particles, and cohesion between the particles. Now, when the density is more, okay, uh, when the density is more, the interlocking of the particles will be more. Hence, uh, greater will be the shear strength. Okay, more density leads to uh, more interlocking, and which leads to uh, high shear strength. So more density, more interlocking, therefore higher shear strength. The next factor affecting the cohesionless soil is confining pressure. Okay, confining pressure meaning if you take a soil mass like if this is my soil mass, if we consider a soil element, okay, is it free on all the sides or is it confined by soil particles, or it is surrounded by the soil particles from all the sides? Now this single element of soil, it is surrounded by soil particles in all the three directions. Okay, hence the pressure applied by the surrounding soil elements on this particular element. Now that is confining pressure. Now, if you consider confining pressure, shear strength, okay, it increases with confining pressure. If the confining pressure is more, then its shear strength will also be more. So, sorry, more confining pressure meaning more shear strength. Okay, this is when you are conducting experiment in lab, but when you come to field, the actual reality, okay, for a range of confining pressure, okay, in the common field problems, the effect of confining pressure is insignificant. So this confining pressure affects the shear strength when you are conducting experiment in a lab, in laboratory conditions. Okay, the confining pressure has effect on shear strength, but when you go to field, okay, the confining pressure, the effect of confining pressure is insignificant. This is only in the lab. When you go to field, it is insignificant. Insignificant in field. Okay. Next factor that affects shear strength of cohesionless soil is vibration or repeated loading. Okay. Usually, I told you one of the concepts, vibroflotation. Okay, when we were dealing with compaction of soil, vibroflotation. Okay, it is used to compact sand, cohesionless soils. Okay, the foundation soil of Burj Khalifa. Okay, it was the strength of that particular foundation soil was increased by vibroflotation. It increases the density, leading to increase in the strength. So I'm just giving an example in field why, how, where vibration is applied or where repeated loading is applied. Okay, when there is vibration or when there is repeated loading, as in the case of vibroflotation, okay, now because of this vibration and repeated loading, obviously the shear strength is going to decrease. Okay, there is decrease in shear strength because of vibration and repeated loading. The last factor that affects the shear strength is capillary moisture, or simply moisture content of the soil, or the saturation of the soil. Okay, okay, sand, it has a little cohesion, and if there is a little moisture present, that cohesion is destroyed. Uh, And also, if there is water present in the sand, okay, it gives a lubrication effect, resulting in the decrease of the friction. Okay, the strength of the shear strength of the sand is mainly due to the friction between the soil particles, because there is little or no cohesion. And when you add water to the soil mass, okay, uh, that water, it gives a lubrication effect, decreasing the friction between the soil particles, and hence the capillary moisture, or if there is moisture present in the water in the soil particles, it is going to decrease the shear strength. So these are the factors affecting shear strength of cohesionless soil. Shape of the particles, gradation, density, confining pressure, vibration or repeated loading, and finally the capillary pressure. The capillary moisture. Next, we have factors affecting cohesive soil. Now, the factors affecting cohesive soil are, okay. The first factor is, uh, when we are talking about cohesive soils, we are talking about clay soils. So the first factor that affects the shear strength of clay or cohesive soil is saturation of clay. Now, if the soil is saturated, okay, as you increase the saturation, the shear strength decreases. So increase saturation, it leads to decrease in shear strength. Next factor affecting shear strength of cohesive soil is clay content. Uh, Now, if it is a well graded soil, that is, it contains it contains soil grains of all particle sizes, of all the sizes. Then, if the clay content is more, then its shear strength will be less. If it is a sandy clay, if it is a clay gravel, then if the content of clay is more in those types of soil, then it leads to decrease in shear strength. More clay content, less will be shear strength. Next is drainage condition. Drainage condition meaning, in the soil mass, okay, obviously the water is present in the soil mass. The soil mass will have some moisture content. Whether this moisture, it is allowed to drain or it is not allowed to drain. Okay, if there is a impermeable layer at the bottom, okay, the water in the soil mass will not be allowed to drain in the bottom direction. Okay, and if there is an impermeable layer at the top also, then the drainage is not allowed. Then the water cannot flow in the upward direction, nor the water can flow in the downward direction. So there is no drainage in this type of soil mass. Okay, if the upper layer is not there, drainage is only in upward direction. In downward direction, there is a impermeable soil. The water cannot penetrate this impermeable soil. So drainage is only in one direction. Here there is no drainage. Okay, so drainage conditions also affect shear strength, because we have to consider the drainage condition, because cohesive soils, they have low permeability and its shear strength depend on whether it is drained or undrained. And if there is no drainage, that is if the soil is undrained, undrained soil have very low shear strength. Okay, so please remember drainage condition. Okay, depending on whether the water in the soil mass is allowed to flow. Okay, if the soils are undrained, that is if the water in the soil mass is not allowed to flow, it remains in the soil mass. If the soils are undrained, it will have very low shear strength. Okay, the next factor affecting confining pressure is the next factor affecting the shear strength of cohesive soil is confining pressure. Again, the shear strength of the clay increases with increase in confining pressure. Okay, more confining pressure, more will be shear strength. But the shear strength of the clay increases with increase in confining pressure, provided there is enough time available for pore pressure to be dissipated. Okay, when you are applying pressure, okay, the pressure is applied on the soil particles as well as the water present in the voids. Okay, when the pressure applied on the water present in the voids is called as pore water pressure. Now, if this pore water pressure is allowed to dissipate, then more the confining pressure, more will be shear strength. And because, okay, in the undrained soil, okay, this pore pressure, it cannot be dissipated. Okay, and hence it leads to very low shear strength. The pressure, it cannot be released. Okay, it is applied on the water present in the voids. That is, pore water pressure also increases. It cannot be dissipated, and hence the undrained soils have very low shear strength. Okay, the fifth factor is plasticity index. Okay, plasticity index. We came across this term when we were dealing with consistency limits or consistency indices. Liquid limit, plastic limit, shrinkage limit. These are the three consistency limits. Now, if the soil is in plastic state, okay, if the water content is more plastic limit and less than liquid limit, then the soil is said to be in plastic state. Now, if the soil is in plastic state, that range is called as plasticity index. Okay, more the plasticity index, more the range of this plastic state, lesser will be the shear strength. More the plastic range, lesser will be shear strength. Okay, the last factor affecting the shear strength of cohesive soil is stress history. We'll come across this when you're in the next module. Okay, stress history meaning the shear strength of the shear strength of the clay. It depends on whether the clay is normally consolidated, under consolidated, or over consolidated. The meaning of these terms you will understand in the next module. But just remember uh, the stress history of the soil, whether the soil was heavily loaded in the past or the soil was not at all loaded in the past. Okay, this also affects the shear strength of the cohesive soil. So these are the factors affecting shear strength of the soil. Okay, and it is different for cohesive soil and it is cohesionless soil. Okay, the next topic is a small topic: sensitivity of clay and thixotropy of clay. Okay, so cohesive soils. Okay, when you deal with cohesive soils, okay, they have a definite particle structure developed during the original process of the soil formation. I told you the type of soil structures for cohesive soil. Either it is either flocculated or it is dispersed. Now the soil structure shown in this picture, in this image, okay, it is dispersed. So originally when the soil is formed, okay, the soil structure shown here is flocculated soil structure. Originally when the soil is formed, it will have a particular uh, structure. So when you, and also the particles are oriented in a particular manner. When you're dealing with, okay, in the construction place, okay, such soil structure, it is disturbed by loading. Okay, loading or transportation of soil. When you load the soil or when you transport the soil from one place to another place, okay, the soil is remolded, and this remolding of soil, it changes its engineering properties. Okay, when what changes occurs is uh, first, and because of these changes, the soil loses its strength. Now, this loss of strength is because reorientation of soil particles. Okay, when there is remolding, there is loss of strength. That is because rearrangement of the soil particles and also rearrangement of the water molecules. Okay, that is adsorbed water. Now, sensitivity, it is when you apply load on the soil, okay, the soil gets remolded and hence the soil loses some of its strength. Sensitivity is defined as unconfined compressive strength of undisturbed soil, that is before remolding, divided by unconfined compressive strength of remolded soil. So obviously, the strength of undisturbed soil will be more than remolded soil. So sensitivity will of the soil will always be more than 1. What is compressive unconfined compressive strength? You'll be learning it in the uh, subsequent classes. Okay. Now, depending on the sensitivity of the soil can be, okay, it can be grouped as insensitive, little sensitive. Insensitive meaning it will not lose much strength. Little sensitive, it will lose little strength upon remolding. Okay. If the sensitivity value is between 0 and 1, it is insensitive. If the sensitivity value is between 1 and 2, it is little sensitive. If the sensitivity value is between 2 and 4, normal sensitive. And if the sensitivity value is between 4 and 8, it is sensitive. And if it is between 8 and 16, it is extra sensitive. Okay, for sensitive soils, the loss of strength is up to 60 to 70%. Okay, if the sensitivity is more than 16, then it is called as quick clays. And these quick clays, they are very unstable. And if any extra pressure or load is applied, the soil is going to fail. And high sensitive soil or quick clays, they are not desirable for foundations. Hence, these extra sensitive or quick clays, they are not desirable for foundations. And for some soil, fissures and cracks are present. And when these fissures and cracks are present, the strength of remolded soil will be more. Because of these fissures and cracks in the undisturbed state, strength will be less, and after remolding, the strength is going to increase. And for such soils, the sensitivity will lie between 0 and 1. So you have to check whether the soil mass comprises of cracks or fissures. Okay, the next concept is thixotropy. Before that, sensitivity. Okay, when you the strength of the soil in undisturbed state is different, and after you work with the soil or transport the soil or load the soil, okay, the soil is going to get remolded, and after it is remolded, it is going to lose some strength. And this, the strength before remolding, that is in undisturbed state, divided by strength in remolded state, is called as sensitivity. Coming to thixotropy again, after remolding, okay, that is because there is change in structure of the soil, or there is change in arrangement of the molecules, the soil is going to lose its strength. Now, so remolding, it changes the engineering properties. Now, this loss of strength of soil, it happens due to change in molecular structure, change in the soil structure. Now, and all these changes are happening at a constant water content and at a constant volume. Now, this loss, now after the strength is lost, if you allow the soil to rest for some time, again there is a gain of strength. Okay, initially the soil is in undisturbed state, and after remolding, the soil loses strength. Soil loses strength because of distortion of soil structure and molecular structure. And after, if you allow the soil to rest for some time, the soil will gain strength with the passage of time. Okay, and this process of strength gain and strength loss is called as thixotropy. Okay, undisturbed state, then soil is remolded, it loses the strength, and if you allow the soil to rest for some time, okay, with the passage of time, the soil is going to gain the strength, and this strength loss and strength gain process is called as thixotropy. So if you now this strength regain is due to the rearrangement of the the molecular structure. The molecular structure, it gets rearranged, but the strength recovery is not 100%. Okay, the strength won't go back to its original state but only up to some extent. So the strength that is lost due to rearrangement of the soil particles, it won't get back. The soil, it cannot be again arranged back to its original state once it is remolded. Okay, after remolding, the arrangement of soil particles, it cannot go back to its original state. Only the molecular structure goes back to its original state. Okay, so whatever strength is lost due to rearrangement of the soil structure, it is lost forever. But whatever strength is lost due to rearrangement of the molecular structure, it can be it can be gained with the passage of time. So if you plot a graph of strength against time, okay, and if this line, it represents the original state or the undisturbed state. Okay, we remodel the soil. Okay, it loses its strength, and if this portion, this amount represents strength loss due to distortion of soil structure, and if this portion represents strength loss due to water molecule reorientation. Okay, with the passage of time, there is gain in strength, but the gain in strength is only due to rearrangement of these water molecules. The strength that is lost due to distortion of soil structure, it is lost. You cannot gain back this strength. The soil particles cannot be, okay, it cannot go back to its original arrangement. So the strength gain is only due to the water molecule reorientation. So the sensitivity is always going to increase, and this is called as thixotropic hardening. And soil on remolding, it becomes soft as it loses strength, and after, with the passage of time, it will harden, but only a little. It won't return to its original state. So these are today's topics. I'll just quickly revise sensitivity and thixotropy. Sensitivity, okay, there is remolding of clay, and because of this molding, there is loss of strength, and the ratio of strength of undisturbed soil divided by strength of remolded soil is called as sensitivity. And thixotropy is in undisturbed state, okay, we have shear strength, and after remolding, this strength decreases, and with the passage of time, there will be gain of strength. Now this strength loss and strength gain phenomenon is called as thixotropy. Okay, so these are today's topics. We'll meet again for tomorrow's class. Okay, thank you for attending today's class. We'll meet again tomorrow at 10 o'clock. Okay, tomorrow there is no class. Tomorrow you have survey lab. Survey lab is at 12 o'clock. So tomorrow we'll meet at 12 o'clock for survey lab. Okay, that's it for today's class. Thank you.